Welcome, greetings from Canada, and namaste to everyone. My name is Gopinathan Paliyar. People usually call me Gopi, and so it has stuck to me for a long time now. So I am originally from the state of Kerala. I was born and brought up in an agricultural family, and all my early years, at least up to 30 years, I was in India. And so a significant portion of which I spent in Karnataka. So I have been a faculty member at the University of Goa since around 1993. So when I started my work at Washington State University, the focus was primarily on senescence, plant senescence, what the mechanisms are. But it was more in relation to apples, how we can keep apples longer, how we can prevent its deterioration. So that sort of studies. And so that I continued after moving to Canada, looking at the fundamental mechanisms of what is happening with respect to the membrane. So this is what led to the discovery of the hexanol-based technologies. So I will go into that in detail. This study in fruits and vegetables, this gradually led me into the health aspects of fruit and vegetable consumption. You may know that people in India, they don't consume enough fruits and vegetables, even though we produce a lot of fruits and vegetables. Most of it is lost, as Avarna mentioned. So the functional foods are those which has got that health benefits. So that is another aspect of my work which I won't be touching up today. But the importance of fruits and vegetables are because of its health benefits. And recently now we have entered the nanotechnology, where we have isolated nanomaterials from fruits, and we can use it in multiple occasions. For example, for agriculture, for preventing the use of the pesticides, herbicides, etc. And we can also use it in medicine for the transportation of medicine, the drugs that are not normally taken up by the body. So I'm talking about all these in the context of food security. Now, recently we're talking more and more of food security, and the issue is that population is going to go up, and we assume that we won't have enough food produced by 2050 or whatever the time period is when the population hits 9 billion on Earth. And so many people are promoting increased agriculture, but increased agriculture comes at an expense because we are utilizing more and more of land. We have to destroy more forests. And so this is going to cause more of a drastic change in the climate. So we are trying to avoid that. Very few people look at the aspect of preventing the waste. They don't recognize the waste that's happening in the agricultural sector. Nearly between 30 and 50% of what is being produced is lost. So if we can prevent this loss, then we will have enough food for everybody. So that is the strategy with which we are coming in. And of course, the climate change has created a lot of problems. The unpredictability in the monsoons and the rains. So it's not only in India, but it is in Africa. So they cannot plant anything based on the usual rain patterns they used to get because rains may not come. And the other aspect I'm looking at is how the agriculture can be shifted to a more environmentally friendly agricultural practice like greenhouse agriculture, polyhouse agriculture, which is probably going to be the one that's more prevalent in India, because the population base in India is going to shift from rural to urban, and there will be nearly equal amount of population distributed between the urban and the rural environment. And the people living in the villages, they have to produce the food and they have to supply this to the urban centers. And how is this going to be achieved? How are they going to do this? So that is one of the biggest issues that we have to look into. So primarily, I'll be talking about this the technology, post-harvest technology that I developed nearly about over than 20 years ago. Unfortunately, because of the business environment, it didn't see the light. But many people are practicing it. It's even being tried out in India, Africa, and many parts of the world on an experimental basis. In the state of Tamil Nadu, they use it routinely, whether it is approved or not, but they like using it. But the issue is that the product is not available. Now industry is making it. Maybe farmers can themselves can make it. So it's very easy. So that's what I'm going to stress in this talk. So, so in the past, we had this green revolution somewhere around 1960s, and it was a big success in India. Because that was time when Professor Swaminathan was the director of the Indian Agricultural Research Institute. And so they got these new strains of wheat from Mexico, where Dr. Norman Borlaug was developed these, and they got so many tons, and then distributed it, and they developed their own varieties. So it was a big success so far as the wheat was concerned, but it wasn't a great success in the case of rice, because there was a lot of environmental issues with rice, because I experienced it on hand. And so right now the stress is on reducing the post-harvest, primarily the post-harvest, or the loss happens all across the value chain during the production, during the transportation, during storage, and so all this can be considered as a post-harvest loss. Processing. So our focus is on this aspect right now. So about 20 years ago, we discovered the XNR can inhibit a key enzyme involved in the deterioration of the produce, the damage of the produce. So if we can prevent this, then we'll be able to enhance the technology, enhance the shelf life of fruits and vegetables. I remember as a child getting bunches and bunches of bananas, 10 or 20 bunches at a time, and how can we finish it? So a lot of it goes to waste. So that was the dream at that time. And so now we know that we can use this technology for extension of shelf life of bananas, mangoes, oranges, papaya, and so many other fruits. So we'll go into this detail. So in India, one of the biggest issue is the transportation. So you see how this is still being practiced, and so something has to change. People have to change the outlook, and so many of the produce gets damaged. So this is okay. Use it the day you pluck it, and you cannot store it too long. So the lack of the storage and the poor transport facilities, this is one of the biggest problem in India's the agriculture sector. Especially this is significant in terms of the fruits and vegetables. You know that the fruit, say for example, apples that are being produced in Kashmir, it has to reach the southern part of India. The way they used to ship it is they put it in a truck and then cover it with a tarpaulin and then send it. And so while it's going southerly direction, the temperature increases and all the fruits get damaged. And I haven't seen a single good apple in Kerala. Everything has superficial scald or interior it is damaged. It doesn't taste good. So all these aspects can be solved by properly planning the production, transportation, storage, all these issues. So India has to look into this particular part, especially when it is entering the 21st century. So this is a typical scene where people taking their produce to the market. This is okay in terms of a local market. We do this here too, because this is how the farmers, their operations generally happen in the market, farmers market operations, where they take the local produce to the market daily or twice a week and then sell the produce. But again, you see the mangoes put in bags and so many things. So the shelf life is low for all these. So the rest goes to waste. But this is just a sustenance. So people have to follow this, but they can do it probably in a better organized fashion. So this is, oh yeah, this is in Cochin, in Fort Kochi, Kerala, how they transport the plantains. Plantains have thick, at least skin, so it won't get damaged. But this is not the way to transport the fruits or vegetables. Again, this is in somewhere in the west coast of Africa. They produce a lot of plantains. Probably this is going to an industry where they are going to skin it and use the interior to make starch or I don't know what. So yeah, so this is the way things are being shipped. So which is not very encouraging for fruit and vegetable preservation. Coming to apples and Kashmir, you see how the apples are piled up, and he's just this person simply standing there. And so that's the apple we are getting to eat. So if you look at these apples, you can see how many of them are, you know, literally not of good quality. These apples won't pass the standard for eating apples in Canada. So this will be more like a juice apples. You can see the blemishes or damage to these apples. And so India has a large area, say starting from Kashmir all the way to Assam, except the Nepal and that area, where fruits can be grown. These temperate fruits can be grown very well. And so this is something that has to be exploited or that has to be used for the good of everybody. And recently, I came across the information on the Harman 99 or that type of apples, which can be grown in multiple climates because it is very weather resistant, which is an advantage in India. And this is wonderful. So that sort of strategies should be used for the advancement of horticulture, especially in relation to fruits and vegetables. I want to draw your attention to this whole area. So you see the apples piled up here. These are probably delicious. So you see this coloration here. So this is superficial scald. So these are scalded apples. This can't be sold here. But so it's all being packed and then probably it's going to send to market. You see these apple trees in the background. See this. These are about, I don't know, more than 50, 100 years old. And the productivity might not be that great. So this is more than an acre. And with advanced agricultural methods, for example, the high density agriculture, you can have at least 1,000 plants in this particular area. And the production can be modified. You get better quality apples. So these apple trees should be cut down and then should be going on, or people should go into high density agriculture. So that is the way of improving the agriculture here. And so if India wants to become a $5 trillion economy, the agricultural production has to be increased this way. And you can also have to reduce the waste of agriculture as well. So there are two aspects to it. So I was in Uttarakhand maybe about 10 years ago, I guess. So we were trying to develop a project with the G.V. Pant Agricultural Research Institute at Ranikhet. And we didn't get the funding because there was so many administrative rules in India and the institution was not allowed to get foreign funds. So the project was gone. But you look at this topography. So you see what they do is a subsistence agriculture right now. So they plant wheat here, and that basically that's it. They get a harvest, and then the weather changes, and they are not able to do anything. But instead of this, if they were to do the, say for example, apple cultivation, pear cultivation, or peach, they do that, but they can increase it further if they have provided storage facilities. They can have an appropriate transport mechanisms, sale mechanisms, all that sort of things. So you can have trees growing across these rows instead of growing wheat. So this is the whole scenario from Kashmir all the way till Darjeeling. So India has a lot of the utilization to do with these hilly areas where they can increase the fruit cultivation. So again, planning of what one cultivates and what is going into the market, that's important for the survival of the farmer. Because, I mean, I hear about farmers committing suicide. That is primarily because not really thinking into the future, what is happening, what the market is, and they cultivate one particular thing and it collapses, and they don't have a way of paying it back. So that is very that's not an advantageous situation. So here, for example, I know about somebody who did this in Kerala. So he had 5 acres of the brinjal cultivated, and he spent lakhs of rupees cultivating it. But then, when the time of field, he took it to the market, and the one they told 20 rupees or something per kilo, and so that would have paid him enough money for what he invested. So he plowed out the whole the plants into the field, and that is just a waste. So, for example, see this field here. So here's brinjal working here, and the probably tomatoes in the background, cabbages here. There's something else in the background, so which I can't see now. And so he's taking this probably to the market. And so this is the right stage of harvesting tomatoes, mature green, and so they will ripen properly. So it can be stored quite. These are plum tomatoes; it can be stored. So diversification, using multiple crops in a field. I mean, not simply relying on one particular crop. That is the strategy for the success of the Indian farmer. Provided if somebody has, say, for example, 500 acres, okay, you can cultivate something. So it is not industrialized agriculture in India. Mostly industrialized agriculture occurs probably in Punjab or that area where there's a lot of land and they cultivate a lot of wheat and that sort of crops. But most of the farmers are small farm holders, and so for them, it is multiple crops that are of value. And with India has a long growing season, so the recurring crops in the field. So that is a better strategy for the Indian farmer. And when it comes to the fruits and vegetables, the biggest problem is the waste. It happens everywhere. It happens in Canada. In Canada, the northern part where it's too cold, they don't get enough fruits and vegetables. For example, a watermelon may cost $50 somewhere in the north. $50 is like 2,500 rupees for one watermelon, and they cannot afford it because everything has to be transported from the south to the north, and it's a long distance. And so they even processed food they simply throw out because of the system, because the label says okay, best before this particular date. It may be good inside, but they just throw it out. So that sort of things happen. Vibhor. Saying Great Britain is one of the biggest wastes. In European Union, 22 million tons of food waste occurs annually. And so they say about 80% of this waste can be prevented. So that's a huge amount of food that can be saved. This was came up in Business World recently. So I put this quote from Business World: "Food wastage cripples a country's economy to an extent that most of us are unaware. If food is wasted, there is so much waste of water used in agriculture, manpower, electricity, food processing industries, and all these are taken into consideration. The loss is tremendous. For example, it can be, say, this rough estimate, 58,000 to 100,000 crores. But my assumption is that this is much more than this when it's taken into consideration. So that is the importance of enhancing or preserving the food and vegetable shelf life. So in about 2011, this was a report from Gustafsson, sponsored by the Food and Agricultural Organization, where he studied the loss of food products across the value chain. So what you see is the percent loss. So you see we are hitting 50% in some of these areas. These are different regions of the world. So this is Europe, North America, industrialized Asia, Africa, Sub-Saharan Africa, North Africa, Southeast Asia. So you see this is the loss during production. So it's about 20%. And then from this on, it's all post-harvest. A lot of waste occurs during the processing, transportation and processing. And so that's the same case in South Asia too, India too, and Latin America. And this is the part where consumers throw out things. So they buy things, they put it in the fridge, they don't use it, and ultimately they just throw it out. So it ends up in the landfill. So you see it's very low in Africa and Asia, but very high in Europe and North America and industrialized Asia. So this is one thing which has to be stopped, reduced. And so we are, at least we are aware of this problem now. We will educated better. And so when you look at per capita loss, so this is total production, and so this is how much is being thrown out. So it's about 1/3 of the food that is produced is being thrown out in Europe and North America. It's much lower in Asia. So this practice has to be stopped. So this is becoming more aware. People have to make increased awareness and about the situation and act accordingly. So these are peaches from Uttarakhand, and these are beautiful peaches. I mean, I can't say how nice it is. So I haven't seen these peaches actually, because this has got a typical spout here. And so the peaches in North America, like in what you get in Canada, US, it doesn't have this particular thing. So this was unusual. So how many people know? How many people think how fruit sprouts stay here in from Gause, Badek. So from the village to the city, that's transition. So this is what we have to be more aware of, and that is what is going to be the future. And so we have to have the best situation where they can produce, they can store, where they can transport and ship it and transport the fruits, and then so that it reaches the proper market and consumers get it. That is the important thing, because if it's half rotten and consumers get it, there is no point in doing any of this agriculture. So this is something in the IIT developed some methods of storing. This is primarily based on air, but this is in India. Everything is kept. So this is probably the future, where you have to have everything transferred, or there should be an organization which is involved in getting the produce from the farmer, sorting it out, cleaning it up, putting it to market. So the value must increase as much higher. For example, here also the same thing happens. So taking apples, for example, if grower who grows apples, he may get, let's say, between 25 and 50 cents a pound for apple. But when it comes to the supermarket, the price for 1 pound of apple is like $2, sometimes $3. Organic apples can be $4 or $5, which is like 250 rupees a kg, something like that. Yeah, so it becomes very expensive. So the farmers really don't get that much of an effort. So what the farmers do, they have organizations. So they form associations, and the association looks after the sale and the distribution of their produce. So they have huge storage areas. So they produce apples, and during this time period, they bring it all to this particular central location. Everybody stores their apples there. And so this particular organization has the account of where the apples came from, what the condition is, where it is stored. So they have RFID tags for everything. So they know that they packed and kept it, and they deal with the people who buy apples. So they determine the price. So the farmers never lose out. So there's advantage like that. So that India probably has to move into that model. So this is Mexico. So Mexico, you see, it's not too advanced than India, and you see, this is a typical fruit market with a lot of fruits, watermelons, rutabagas, and all the vegetables. And so we can do these sort of things even in India, everywhere. So I saw this recently. These mangoes, they look at beautiful mangoes, fresh, ripened, uniform, and I can't find anything better than this. And look at the way it is kept. Look at this rotten box. So packaging has a big effect on the shelf life of the produce. So they have to find better ways of storing mangoes, shipping mangoes, and processing mangoes. So now we are coming to a little bit of science, and so there are two key things. Ethylene is the hormone which causes the ripening in fruits. So I don't know whether you have seen this, but in olden days we used to put smoke. So when we get bunches of bananas or mangoes, we have a room. So we keep all these mature fruits in the room, and then we put, say, take coconut husk, put some rice husk, and then put some embers, burning embers, and the fire comes out. So it gradually it smokes, and the smoke contains ethylene, and so that helps the fruits ripen. And the ripening process is complex. There is gene expression involved in it. There are so many signal transduction process. So it's a whole biochemical machinery from transition from a mature fruit to a fully ripe fruit. So usually there is softening of the cell wall and the membrane. Uh, the cell wall softening results in the softening of the fruit. You cannot eat a rock-like fruit. So this is needed during the ripening process, but it shouldn't be too much. And similarly, the degradation of membrane, that's another aspect. So we have to prevent these or slow down these processes. Once we slow this down, we can enhance the post-harvest shelf life and quality. So there are enzymes which cause cell wall degradation, so you can inhibit it. Remember the enzymes that degrade membrane, so you can stop or reduce their action. So automatically it will increase the post-harvest shelf life and quality of fruits and vegetables and flowers. So that is a strategy we are going to use. So how did we come across? So I was working on understanding the mechanism of what happens during the damage to the fruit occurs, especially to the membrane, cell membranes. So that is when we discovered hexanol. What is hexanol? Hexanol is the same thing. It's a cut cucumber smell. When you cut cucumbers, you get a flavor, and that is because of this particular molecule. It is produced from lipids. So when a tissue is cut or wounded, the system starts degrading, and the phospholipids in the membrane, they start degrading and producing this particular compound. So that's why you get this flavor. You cut the beans, you get the same flavor. So this is easily synthesizable, and so this is a volatile liquid. So when you keep it, it just volatilizes. It's approved for food use. in the US. It's called as generally regarded as safe. It's called GRAS status, GRAS, GRAS status. It is used by food industry in the US for putting in chewing gums and things like that for this green flavor. So it's a very refreshing flavor. And so it's currently used, widely available, and it's very inexpensive. So that is what we are going to use for enhancing the shelf life and quality. So what does hexanol do? That's one question. So when you cut the tissue and look at the tissue under electron microscope, you can see so many things that are minute. For example, this is the cell wall. So this is cellulose fibrils. And below that, you have this membrane, plasma membrane. So you see these dots here distributed. Those are all proteins. So what is membrane in cell wall? It gives this compartmentalization. It doesn't let the system break down. So it keeps the structure. But as the tissue starts maturing, aging, senescing, so you see here, the proteins start moving away because degradation starts in these areas and moves this protein out. So these are all areas where the lipids are damaged, the membrane is damaged here. And so these areas become leaky. So actually there is so many things stored over this membrane in this cell wall compartment. So it's filled with fluid containing calcium, protons, etc. And they will start leaking into the cell. And so that stimulates many of the enzymes in the cytoplasm. And so that is the damaging aspect of the senescence or fruit ripening or stress, many things. This is a common mechanism. So this is taken from an article I published in 1991. So going to be 20 years. So what happens in the membrane? So this is the, so there is a phospholipid bilayer in the membrane. You see there are two layers of the lipid. So this, because it's hydrophobic, it's amphiphilic. There is a water-loving portion, there is a fatty acid side chain, so lipid. So it forms structures, flat structures like this. So it compartmentalizes. So there is more of calcium and proton outside and less inside. So this is the outside, this is the inside. So when the tissue sees ethylene, ethylene binds to a receptor it recognizes like any other hormones, and it causes gene expression. It activates this enzyme, phospholipase D. So phospholipase D starts degrading these phospholipids. And so it produces an intermediate called phosphatidic acid. Then that another enzyme acts on this and produces this particular compound. This enzyme acts on this and produces fatty acids. And so this gets broken down in so many compounds. So when they accumulate, the membrane gets damaged. So what happens when the membrane gets damaged? So this calcium, this everything, it starts leaking down inside. Once it starts leaking on inside, the concentration increases. And when the concentration increases, it activates phospholipase D. So this is a cycle. So once it starts, it's an auto-catalytic cycle. It breeds on its own. It increases the activity by itself. So it goes around, in the consecutive cycles. So the only way to stop this is stop this particular enzyme, because these enzymes cannot act on the phospholipids. Only this enzyme acts on the first step. That's the first step. So if you're able to block this, this whole thing will slow down, or you can block it. So that is what hexanol does. So it can slow down this whole process. And because of it slowing down, it doesn't change the quality of the produce. So when the fruit ripens after 30 days or 40 days, it still is excellent. So this doesn't affect the quality like another compound called 1-methylcyclopropene, which is being used in apple solution. It turns apple into a rock, but You can keep it for a long time period. But hexanol is a much better preservative as compared to that, because for tropical produce, fruits coming from tropics, you need it soft. You cannot have it hard, rock hard. So for that softening process, this is ideal. It doesn't affect that. So we had a couple of patents on this. This one is expired, 651 for 2020. And there's one more which is valid in India for another 5, I think about 10 years. So we made primarily three products. Two products based on this patent. So one is a formulation, a hexanol formulation, or we also call a composition. Just make it in with the detergent and water. So we use this for pre-harvest spraying of the produce. So we do this before harvest, and we can also use it as dip. After the harvest of fruits or vegetables, we can use dips. So not all produce can be treated like that. There is a characteristic method that you can use for a particular fruit. Sometimes you can use both in some cases. So one key aspect that one has to remember is that this treatment has to be done before the fruit ripening starts. If the fruit has started ripening, if the tomato is, for example, already orange red and you start dipping in solution, it's not going to do anything. So you have to do this treatment before the fruit ripens. This is very critical. So in many industries, initially they borrowed this chemical from me, this composition from me, and they don't seem to understand that they have to give the treatment on mature produce, not on ripe produce. And because of that, it didn't work. So all the treatment has to be done before the fruit really starts ripening. So usually the treatments are done 15 or 30 days before the harvest of the produce. Or if it is like tomato, you harvest it when it is still green, mature green, and then dip in the solution. It will keep for 40 days. Or you can use hexanol as a vapor. I told that this is a volatile liquid. So if you keep it open, it will just evaporate. So based on that, there is an equation we can calculate. I'll take you to the end. So we use about 0.01% to 0.05% weight by weight. That you have to calculate. And you expose the produce for about 12 to 24 hours in a closed chamber or a room. That's all what is needed. And the produce will keep for 3 weeks. So usually for this, we take the stock hexanol solution and then we dilute it with water to 50 liters. This is enough for 1 acre. So 1 liter of the stock is enough for this. So 1 liter of this stock solution contains 10 ml of hexanol. So that's all what we are using. Similarly, dip treatment. So the dip treatments usually takes about 3 to 5 minutes. So you immerse the produce in the solution for 3 to 5 minutes. You take it out, leave it in the room temperature. Next day you can pack it, put it at 10 degrees to 15 degrees because these are tropical. So you cannot cool it to 4 degrees. So that will damage the produce. Never keep tomatoes in the fridge. Always it should be at between 10 to 15 degrees Celsius. So this is just the composition of what we do. So we use hexanol, 1 volume, 1%. Surfactant, 20 is a surfactant, it's a food grade surfactant. It's like a soap. So it makes it stick to the fruit. 10 times that. And alcohol, without any additive. It should not have any other denaturing agent. Because sometimes people add methanol, dimethyl ketone, etc. to ethanol. So to denature it so that people won't drink it. Some people still drink it. So this is the composition 1 to 10 to 10. And when you make it like that, you get a stock solution. And the stock solution looks like this. It's very clear. Otherwise, it will be a cloudy liquid. So when you dilute it, to 50 liters in water, it becomes tiny droplets in 9 nanometer, 10 nanometer. So it's 100 angstrom, so very tiny. That's size of the droplets. And so this is very stable, the zeta potential. So if you keep this, you can keep this solution for 2 years, 3 years, nothing happens. It's fine. So but once you make it into a working solution diluted with water, you cannot store it longer, not more than 24 hours. So that is one thing to remember. So I'm going to talk to you about some of the experiments we have done with respect to the fruits. So these were some of the first trials we did. So this is Eider red apples from in Canada. So rows of fruits and the trees. So this is the control where we left it without treatment, and this is treated with the hexanal formulation. So we dilute it to 1 to 50 liters and then spray on the trees. So you can see how much the fruits have dropped in the control and how much here. So fruit drop is a big problem because this happens because of the abscission, because once ethylene starts work on it, things just drop. You might have seen mango fruits dropping down from the sky when it is ripe. So that's because of the abscission. So people use a lot of apples. You cannot use this. You cannot sell it in the market. So what people do is they use it for making juice. And so that's all what you can do. So the price drops compensate. They lose 50% of the crop like this. But some apples do this, some apples don't. So for those apples which cause this falling, this can be used. Peaches, they do drop. So there you can use this. Mangoes or any fruit that drops. This is a good treatment for it. So it prevents fruit drop considerably. And this also helps get a better yield for the farmer. So this is another problem with some of the apples. I told you about that when I showed you that red delicious apples, superficial scarred. So use this coloration here. This is only on the skin. You can still eat this apple, but the value of this apple goes down because it doesn't look nice. So this is some problem that happens for some kind of apple. So if you dip it in external formulation, nothing happens. So see, the apples are kept as it was. So you see the redness of this apple is beautiful. So it preserves the apple. So it can stop some of the physiological disorders. Now we know that there is a physiological disorder called called bitter pit. So apples develop some kind of dark spots here, and the apple turns a little bit bitter, and inside it's sweet. So that's a damage. So we know that we can stop this by external formulation. So these are cherries. I'm not sure how many of you have eaten sweet cherries, but it's produced in India. And so this is big cherries and very sweet, nice. So you see how green the pedicels are. So cherries have to be plucked individually, because if these pedicels are detached, then the quality of the cherry is gone. People won't buy, or the value of what farmers get, that's very low. So this pedicel have to stay on this. So how green can you maintain it? So that's one of the issue. So we did pre-harvest trials on cherries. And so this is the control, which was not sprayed. So this is ripe, ready to eat. But that treated with hexanal formulation, you see it's the right step. So it will take another 10 days for this cherry to reach this stage. So we developed another composition with antioxidants in it, and you see it's still more red. So this takes at least 2 weeks to reach this stage. So what essentially we did was to extend the harvesting window by over a month. So usually they have to harvest this within 1 week. So if a farmer has a big orchard, he has some of these trees unsprayed, he starts spraying on some of these. So he can extend and get the produce at different intervals. So what he gets in 1 week, he can get it in 1 month, probably 2 months. So because of that, it doesn't come into the market all at a time. There is no glut. So the price doesn't drop. So the farmer gets a much better yield or much better price for the produce that he has. So that's the advantage in this case. Extend the marketing window, the harvest window and the marketing window of the produce. So this is the same situation for mango also. When you spray on mangoes, the harvesting window can extend from 1 month to 2 months. So right now what happens is that the middleman comes, he harvests everything, the young ones, old ones, everything together, and then put some acetylene, everything ripens, and it's useless. Half of the mango is useless. And so they can stop doing this particular practice and get the best quality produce, because the maturity when it is harvested, that determines the quality of the produce. You cannot take a young mango and ripen. I mean, you can ripen it, but the quality won't be the same. And so this is true of any fruit. It can prevent the fungal infection, fungal growth. So this is strawberry. I hope you have eaten strawberry. In India, they are starting to cultivate strawberry now. And so this was conducted by a company in California. So strawberry has a very very low shelf life. Even here, keep it in the cold, you can keep it more, maybe 1 week. In India, if you harvest, you might get hardly a day as shelf life. Within 2 hours, it will start damaging in the temperature that India has. So you see this fungus starts growing and this exposed to hexanal vapor. And so hexanal vapor slowed down the fungal growth. We have better data now. But strawberry is a very difficult fruit to work with. We know that the pre-harvest spray can also work in strawberry. So peaches, that's another problematic fruit because peach also has a low shelf life. You can keep it in the cold for a long time, to 1 month. But then when you take it out, then it doesn't stay that long. So we have the controls and we have the sprayed. These were sprayed with hexanal composition. So you see, this is after I think 21, 2 weeks or something, or 3 weeks. So it's starting to get damaged. So you see the damage here. So some of this become very soft, while this was dip in hexanal formation. So this was somewhat better. But the preservation was much better when it was sprayed. So this was subjected to pre-harvest spray 14 days and 28 days before harvest. And so that kept it in much better condition. So if you dip it, it's still slightly better. We give a 3-minute dip. So these peaches were really good. So you get a shelf life extension of close to 1 month to 6 weeks. So here, so this after 6 weeks, and it still tasted good. So it tasted this. The controls were all gone, so nothing left. Only this one was left. So mangoes, our king of fruits. In Tamil Nadu Agricultural University, they have done a lot of work on mangoes, so they optimize most of the mango treatments. So you see the way they spray. This is a very safe solution, so you don't need any protection, but it's good to take a protection. So usually you can spray it from outside in, because a lot of mangoes will be hanging around. You can also see most trees, there will be a lot of fruits inside. So you do spray inside out. So you go inside and spray it outside. So that is the sort of way you have to spray the fruit trees. And so once the fruits are mature, this is Bangarapalli, harvest it, bring it in a cold chamber, and You bring it, it's cooled, you desap it, you break the neck, and then all the sap comes out. Otherwise, it will damage the skin. And sometimes wash it. And then, if you want to dip in hexanol solution, this is the way it is done. You just dip it like this. So that's all what is needed. So the froth is because of the tween in it. After 3 minutes, you take it out. You just put it in a cold chamber, let it dry, or you can keep it at room temperature, take it to cold the next day. Doesn't matter. So the cold temperature, the room should be between 10 to 15 degrees Celsius. Should not go below 10 degrees. And then we use it for our studies. So this is what was standardized in Tamil Nadu Agricultural University. So these mangoes were kept at room temperature. This is an ambient storage, 14 days after harvest. So here is the control. It's already ripened. This is for Alfonso, and this is for Banganapalli. So these are two varieties which are very common in the south. So in the north, you get there are some other varieties. So the control ripens. The one which is treated with hexanol is still ripening. So this will take another week to reach this stage. Similarly, for Banganapalli, see the treated one is still green after 2 weeks at room temperature. So a farmer can harvest it and leave it for 2 to 3 weeks without this undergoing ripening. So then only it will start ripening. So that is the shelf life extension that you can get. So again, we are coming across this marketing window. So you don't have to take all the fruits all at once to the market and get 2 rupees a kilogram because there is too much mango. But the farmer has the option to store it and then release his fruit slowly. You don't have to sell everything all at once. So that empowers the farmer to store the materials. So that is what our strategy is. So you can get 30 to 40 days of extension for some mango varieties. So this is the Neelam, another variety, and the Banganapalli again. And so this is after 21 days of storage. This was stored in air, room temperature. So this is controlled. So this is the anthracnose, which is a fungal sort of an infection. This mango is totally damaged. So 21 days is how it looks like. And so the air stored, those two, treated with hexanol. So it ripens and it's still good. And the one in the cold, you can get another month of shelf life on it. So you easily 40 days, 40 to 45 days of shelf life for mango. So there's some science. So the treating with hexanol formulation, so it slows down many of the processes within the fruit when it is ripening. It prevents the loss in weight. Otherwise, water escapes and the fruit gets damaged. Fruit start wrinkling, so it can prevent that. It reduces ethylene, so the ripening process is not accelerated. It reduces respiration. So internally, there is more sugar stored, so it's much sweeter, and it's got a long shelf life. And so if you keep it in the cold, you get a much better effect. And early stage, you can get a reduced drop by hexanol formulation. So these are some of the advantages of treating with hexanol formulation. So somehow the increasing hexanol doesn't stop the anthracnose. For that, you have to treat early. This study was conducted by Dr. Karanbir Singh Gill in Punjab Agricultural University. So he was one of my long distance students, and he did all this study on his own. I just gave him the instructions, and he developed the formulation in Punjab. I didn't even see it. And so he went and sprayed it in the field. We got this wonderful result. How many people have seen a guava after 1 month of storage in cold? So this is controlled, this is treated, and this is 14 days after storage, so its quality is already gone. And so 28 days after storage, and this is 14, this is still marketable. So guava shelf life extension up to 28 days in Goa. So this was published in Post-Harvest Biology in the country. So this manuscript has been viewed over 1,500 times after it got published. So it's a very popular article, very thorough study. So I do have some, so I'm going to talk about this later, but this was supported by Canadian International Food Security Research Fund. And so we had these trials going in multiple countries, India, Sri Lanka, Kenya, Tanzania, Trinidad and Tobago, Canada. So these trials have been going on everywhere. In some countries, they had a different focus. For example, in Kenya, they worked on bananas and papaya. And Trinidad and Tobago, they worked on plantains and citrus. Tanzania, they worked on citrus. In Sri Lanka, they worked on pineapple, papaya, etc., mango. So after this, I had some collaboration with one of my colleagues in Ivory Coast. Ivory Coast, as you know, it is in the west part of Africa, in that area, where Nigeria, Benin, Ghana, Ivory Coast, all the typically tropical, just like southern part of India. And so they grow papaya, mango, all that sort of things that we have. They also have it. So he contacted me. So I have collaboration with this university, Namibia Proco University in Abidjan. So this is some of his trials on papaya. He's doing it. I mean, you see, he's not even wearing a gloves. So you can simply, it's like a soap solution. So you can simply touch it, wash your hands, nothing happens. So it's a very safe solution. So these papaya, these were sprayed before the harvest. So this is the control and this is the treated. So you see how many fruits are there. These fruits are not smaller because they want to accommodate it in the camera. So just moved back and taken the picture. Fruits are of almost the same size. So he's got more fruits, double the fruits here as compared to control because it falls down because of the abscission. So the hexagonal harvest rate enhances the fruit holding onto the tree. It reduces the fruit drop. And you can do treatment, the fruit drip treatment also, for papaya. So this is untreated papaya harvested. So it's ripening on the 8th day. The treated papaya still green. And on 15th day, this is just starting to ripen. So ultimately, you can get about a month of shelf life for papaya. This is plantain. It's not very common in the north, but in Kerala we grow this, Tamil Nadu we grow this. It's very starchy inside. It's a very nutritious type of food. I mean, in Caribbean, they use it raw and use the starch inside as instead of rice. Some people, they ferment that, they can use that. So it's a very healthy food because starch is like a lot of resistant starch. It doesn't get digested fast. The sugar rise is very low. So yes, plantain is a very nutritious type of food. So you see this sun-sprayed plantains. You see it's matured and you can see the fruit which is already split, starch fills inside and then it cracks open. So this is stage to say, people say, okay, time to harvest. So we harvest at this particular stage. But this one which was sprayed, it's still green and it's still going. So again, you see this increase in the marketing window. So that is the advantage here. So banana normally, for example, during the autumn season in Kerala, all the bananas, the plantains come out. Now everybody gets the plantains all the season. But before, when I was growing up, we primarily have it during August, September, and then you don't see it because another date has to come through on the cycle. So during autumn season, we use these plantains, ripened, fried, cooked, all sort of things. So that's all what we had during that time period. This is some of the mango trials in Sri Lanka. They were experimental in doing this. They have a particular variety called Karatha Kolma. This is about huge fruits. So probably a kilogram. One will weigh a kilogram. So huge. See, very nice. It ripens very well. And so that was their trial. This was another study that was conducted in Tamil Nadu with the university by Subdareshan. See, all these are individual bunches. All these are different bunches. So he has done a dip treatment for this banana, and so this is the control, the undipped banana, and this was treated with hexanal formulation. It was dipped in hexanal formulation, and then this set was kept in the cold. But the interesting part is that, see, for example, this ripens by 9th day. It is almost completely ripened, and then it's going down. So while the treated one, it is still good to about say 20 days. And see, for example, here the treated one, for the good quality bananas, can get up to 35 days. So when it is kept as hands, I feel it's hands and treated, it gives a much better result. Bell pepper is the same result. Control is 21 days. It ripens. So this is actually a red bell pepper. And if you increase the hexanol as a vapor, you can keep it green. Again, you can ripen it, but you get a much better double the shelf life. So this is how we do the treatment. You can put take a big polyethylene bag, put the materials in the stackable trays like this, and you keep hexanol, take the hexanol as you need, put it in a beaker or some glass container, put a cotton bead, and you keep it on top. It will evaporate. Hexanol is heavier. It will just come down and treat all the fruits. Just treat it overnight, 12 hours to 16 hours, and then it is ready. It is safe for honeybees, fish, human cells. So we have done, or Tamil Nadu University, they have done all the studies. It's safe for worms. So it's very safe. So this is just a slide of Canada investing $62.5 million for this CIFSRF. A lot of international study went on. Here is our team, myself, Dr. Liam, Sullivan, Subramanian, and this is our Minister for External Affairs. So I'm just going to give you particular statistics. Okay, so when you usually hexanol, it costs 20 kilogram costs about 1,600 Canadian dollars, which is about 80,000 Indian rupees. This 20 kg, 20 kilogram is enough to treat 200 metric tons of produce as vapor. Or you can, if you make it into solution, in combustion, you can spray 2,000 acres. And assuming that you get about 200 metric tons at a price of 25 rupees, that gives you a farmer about 50 lakhs of Indian rupees. If this treatment was not conducted, you would likely lose about 40% of that. That is about 20 lakhs. So you might have got about 30 lakhs. So he must be saving about 20 lakhs per acre. This is a hypothetical situation. So by giving this treatment, spending 80,000 Indian rupees, you can get 20 lakhs of worth of fruits. But if it is judiciously done, people can get more. See, like for some of the high density cultivation, you can get close to 6 tons, 10 tons per acre of guava or mango. This is the applicability. It is the pre-harvest spray for vegetables. It's common. For some cases, it cannot be done. For vapor, some treatment can be done. It's suitable for papaya, mango, guava, greenhouse tomato, bell pepper. For bell pepper, you cannot use pre-harvest spray. You cannot use post-harvest stick, but you can use vapor. So for every produce, you have to standardize what is the optimal condition, what is the optimal concentration, what is the optimal method, what is the optimal time of spraying. So this is just the method of making the solution follow ditto. and you have the solution. You can keep it for um, 1 year, 2 years, no problem. So this is the vapor treatment I mentioned about how to calculate. If you have 100 kilogram of produce and you want to give 0.001%, it is 0.001 divided by 100. So it's 0.01 kilogram or 1 gram hexanal for 100 kg at this concentration. So it is active between 0.001 and 0.001. So you might have to give about 10 ml. So that has to be standardized. So in a situation like this, when farmers have homes and this bitter melons, I think, yeah. So right now the tendency is to go for this. This is a company in India producing this solar-based cold storages, so EcoFrost. You don't need too much temperature. Keep it at 10 to 15 degrees Celsius. So how much cooling do you need? So this is enough. So this is a very neat sort of a way. And so this is the strategy. This should be distributed to farmers. They can get it. I don't think this is going to cost a lot, but banks can give loans, and people can take it. That will be advantageous. Same thing happening in Africa also. So this is Dr. Charles Wilson. He has what is called as the World Food Preservation Center. So we have a lot of sister universities. So around the world, there are over 100 universities, I think, like working on same thing on post-harvest. And so this is in Africa. They have these particular things. So he has this initiative, cold chain initiative. So we should have this type in India as well. So this is focused on Africa. Okay, so these are the agents. And so these are some of the references. That's it.
I have a couple of questions regarding this.
Okay.
So when the hexanal is reacting with the kind of mechanism you showed with some enzyme, so my question is that if this is again a kind of preservative and it's reacting with the enzyme, then do you have studied any impact on the human health of this?
Oh, after feeding
hexanal with the enzyme?
Hexanal by itself is not a damaging compound, because I told you that it's a GRAS status compound. It's used by the food industry. So in the US, so they use it in gums, chewing gums. The people are using it. So they, if there is a health implication, if there is something damaging, FDA won't approve it. Okay, and inside, when hexanal blocks phospholipase D, there is still phospholipase D floating around. So it's only blocking some of these. So that is why if it is totally blocked, the fruit won't ripen. Okay. So still it's going on. What we are doing is simply slowing down the whole process. What takes 1 week at room temperature without hexanal, we are extending the whole process to about 30 days, 40 days. So that enables the farmer to keep his produce for a much longer time period.
And then I have second question about the quality of ripened food. Like it delayed the ripening of the product, agriculture product.
Yes.
So do you think that there isn't any change in the taste because of chemical treatment?
It's improved. It's improved. You get a much nicer taste. So actually, I haven't presented any data. The color is improved. For example, I showed you the cherries. In cherries, we showed that the carotenoids, anthocyanins, all these are increased. So it gets a much nicer color. You might have seen that apples dipped in a solution, much reddish.
Yeah, extremely.
The taste, there's more sugar in it. Like when we take the cherry, treated cherry, and chew it, you can see the toughness. It's crunchy, while the normally ripened cherries are soggy. You bite onto it, it's very smooth. So we get that nice improvement in the quality of the produce. See, the thing is that if the fruit is ripening, it's using a lot of energy to rebuild, because system is trying to compensate for the damage that is happening during the ripening process. So the quality deteriorates much faster. But if there is no requirement to compensate for the lost materials, then the reserve materials are preserved. The sugar is preserved, amino acids are preserved, proteins are preserved. So it gives a much better quality.
So I have two questions. Like, if we say long-term effects, like we put an hexanol on all the trees and all. So will they have a long-term effect? Like fertility fertility is losing, like in Punjab also, where we have seen that fertility is losing.
No, no, it doesn't. Like for example, you are maybe comparing it to paclobutazol. So if you treat with paclobutazol, it remains in the soil or it remains in the plant. So the effect is going from one season to the other season. Whereas in this case, it doesn't. So it is instantaneous and the effect is gone within maybe 1 day, 2 days. Hexanol is metabolized. So what happens to hexanol is that hexanol is converted to an acid called hexanoic acid. And hexanoic acid enters the respiratory breakdown scheme. So it's broken down to produce energy. So it doesn't remain within the tissue. Okay, so there is no problem with it remaining on the plant or produced. There is no residue. You cannot measure hexanol because when you wound the tissue, it produces more hexanol. So how will you measure it? So that is the issue. So there is no residue when you treat it with hexanol. And again, one thing that we noticed is that, especially in Tamil Nadu, like for example, you spray the mango orchard, then there is like a flavor within the mango orchard which retains the next day. This attracts the predators because the predator, the prey interaction, like the entomology, like for example, when something chews on a plant, the plant produces hexanol, and the predator looks at hexanol as a signal to come to that place for thinking that there is a lot of the prey. So it attracts the predators, reducing the pathogen or the insect pathogen. So that is another potential possibility.
So it looks like the trials have happened around the world, in India, Africa, many countries, and so on and so forth. So what is the challenge? Is it adoption at large scale?
Yeah, I didn't explain that much. We tried to commercialize this through several companies in India. So I came in, but we had meetings with Raleigh, we had meetings with Coromandel, and so at this time this was licensed to a company in Canada, and so they were trying to make this interaction. And so what happened was that they told different stories. So it will take a long time, 15 years to get it approved in India. And so, but in state of Tamil Nadu, the government said, okay, you go ahead and use it. So the farmers are using it. But now their problem is nobody is making it. So otherwise, the mango farmers in Tamil Nadu are using it already. So when people start using it, then government doesn't have much of an option other than permitting it. But the thing is that somebody has to produce it. So who is going to produce it? That's why I told that this vapor treatment is one strategy. Even if people are not able to do the pre-harvest, they can do the vapor. If farmers can do it, if they get the hexanol. Hexanol is very cheap, so some distribution scheme through the NGOs or something, if they get the hexanol, they can do it themselves. Or I don't know, we have a next generation product coming. Hopefully, if we are able to launch it, then we will launch it in India. So